that we are doing today is Palindrome Partitioning II. So the goal of this question is to chop the string into pieces where every piece is a palindrome, and you have to do this using as few cuts as possible. So just keep that in your head. Now the first thing that you might notice is that the solution has two halves. So over here on the top I am building a spal, and down over here I'm building DP. So the first half is basically we set up the knowledge, and then the second half we cache it in. Right now I start with n equals to length of the string, and then I build my ASPAL and I set it to false. Over here just notice that I'm using a list comprehension. I am not doing like false times n and then multiply it by n. What a list comprehension does is that it independently builds these rows. Now you have a for loop. So now if you notice, every single letter is a palindrome because every single letter reads the same forwards and backwards. So we set that to true. So when you fill the DP table, this is how we seed the diagonal of the table, and this will be our base case. So this is the ground, and we build everything else on top of this, right? Now this is our major for loop. Now if you notice, we are going by length, so we go from short to long. So first we do two first, then threes, then fours, etc. And this is how you check a palindrome. So in a palindrome, you first check the outer letters, then you just skip them, and then it moves, you peel them off, and then it moves inwards. So if you notice over here, that's what's happening. So I is moving inwards and J is moving backwards. So over here you're checking if S of I is equal S of J. So if you have two pointers on either side of the string, then you're checking if they both are equal. And over here then you're moving inside, and then you're setting it to spal I of J to true. And over here, if you notice, J equals to I plus length minus 1. So you are doing I plus length minus 1 because this length already, you are taking the length, but essentially the length includes I, because this is an index as well. So you are then from the end reducing 1 because you have already included I, when essentially I is already included in your length. And over here you're doing until n minus length plus 1, because if you do anything further it will just go out of bounds. And we are setting it to true, and by default it's already set it to false, so we are just required to set it to true. Now we come to the next part, which is building the DP array. So what we have to do is, it's a new array. So DP of I is basically going to mean that the minimum cuts that I need for the prefix ending at index I. So we will build these from left to right, so which means the smallest prefix will be first, and the biggest prefix can then use the small answers. Now if you check the for loop, in this for loop, we first check is spal 0 I. Now this is the entire prefix from start to I. Is that already a palindrome? If it's already a palindrome, it doesn't need a cut, right? Then we are done. But if it's not a palindrome, we set it to I. What is I? I is the worst case, so in case there are no palindromes, so we have to put a cut after every letter. And then we have this for loop. So what it's doing is that this we are basically asking where should the last piece start. So that's what j is. It's the starting index of our final chunk. So for each j, first, if is pal j I, if this is the last piece, so if you have s of j starting from j until I, if it's actually a palindrome, so that's what you do. Because if it's not, then we are not allowed to use it because we can only use palindromes. So we skip the illegal ones, we check if it's a palindrome, we enter, and then, and when it is a valid palindrome, then we check the cost of this. So what we are doing is that we are breaking that into two pieces. So j minus I, dp of j minus I, is the best number of cuts for everything to the left of this last piece, and we already computed that on our early turn, so it's a free lookup. Sorry. And then this plus one, that's the single cut, so that's the one slice that separates from the left part from this last palindrome piece. And then we have the minimum. We should take the minimum because that's what the answer requires us to do. And then we save it in best. And then at the end we return dp of n minus 1 because we are filling it from left to right, so our n minus 1 will hold our answer.